Dear viewers, today I am going to show the FX controller. The FX controller is a STATCOM. Okay, so in this part I will explain the STATCOM. So first we have only connected the shunt controller. So by using the shunt controller we are working with the STATCOM. Okay, so now for the STATCOM we can select the MCB's position. Okay, so MCB B is on, so MCB B is on. Okay, MCB C is off, so MCB C is off, and MCB D is on and E is on. So MCB D is on and MCB E is on. Okay, so MCB B is on, D is on, and MCB E is on. Okay, load side MCB. So we have only connected the shunt controller. Okay, so all the loads are full load, and in the STATCOM we have only the R load and RL load and RC load. Okay, so we have toggled the switch to RL load or RC load. Okay, so now we have done the code. So by using this program you can just start it, and you can open the code STATCOM code.hex, and you can just download it. Okay, and press OK and disconnect. Okay, now from here you can disconnect it. Okay, and after this you can press the system reset. Okay, so it is FX STATCOM mode. Okay, and now you can make sure your MCB positions are turned on properly. Okay, then you can turn on the MCBA. After the turn on the MCBA, display will be updated. Okay, and you can observe this STATCOM OL means open loop and mode is off. Okay, so by pressing this button you can change the mode to open loop to closed loop. Okay, so first of all we have run with the closed loop. Okay, so now I have changed the mode to closed loop and start the controller. Okay, so by pressing this center button, this center button, you can turn on the system. So when the system is turned on, the display is updated, and here the closed loop, screen 1, screen 2, and all the parameters are written here. Okay, so now you can see this is the RL load, it's full load condition, so it will try to maintain at unity power factor. So this is the unity power factor, it is achieved. Okay, and you can observe from here also. So you can see it is unity power factor. Okay, okay, so you can see this is the unity power factor we have achieved. Okay, so by using shunt compensator we can control the voltage and power angle and try to maintain at unity power factor, and at that time the load and voltage is 116 volt. Okay, so now we have switch to RC load. Okay, so by using this switch we have toggled the load to RC load and see the performance. So I am moving to the waveform. Okay, and you can observe the waveform. Okay, so when I am switching, this current is leading in. Okay, and at that time current is leading and it will try to maintain at unity power factor. So you can see it is try to maintain at unity. Okay, so likewise this STATCOM is working properly. Okay, and you can observe from here the power factor is unity power factor. Okay, and load and voltage is 116 volt. Okay, so this is the full function of STATCOM. Okay, closed loop. So So now turn off the system, and you can toggle this to the open loop. Okay, so by pressing the center button you can turn off the system. Okay, so you can turn off the system, and by pressing this K1 S1 button you can toggle to open loop. Okay, and by pressing this button now turn on the system to open loop mode. So again you can press the center button. Okay, then turn on the system. Okay, now in the open loop, which value you have increased? Okay, so you can see the on this table. Okay, so you can see shunt compensator means STATCOM open loop. Okay, STATCOM open loop. So DEC to S1 switch is for DEC to increase or decrease. Center button is used for the start and stop. Left button, first left button is to select open loop and closed loop mode. After turn on the system, it will toggle to the DEC increase or decrease. Okay, and up and down button, by using up and down button we will increase or decrease the IQ ref. Okay, so we have pressed the, now you can see the voltage and current waveform. Okay, so current is okay, so this is the RC load. Okay, at this time load is RC, so the current is leading with respect to the voltage. Okay, now when current is leading, so we have applied the IQ ref. Okay, so by pressing this button we have applied IQ. Okay, so you can see when I am pressing the button, I apply the IQ ref. It will try to reach at unity power factor. So you can press the down button. Okay, so when you have pressed the down button, IQ ref is minus 255. Increments are there, minus 2.5. Okay, so and is minus 3. Okay, so you can see the voltage and current is around the unity. Okay, it will not reach the unity. Okay, so still some compensation is required. Okay, so we have again pressed the button and it will minus 3.5. Okay, at this value you can see the voltage and current is unity. Okay, so you can see here it is unity power factor. Okay, now same thing we have applied for the RL load. So we have toggle with the RL. Okay, and now RL, at the RL load, voltage current is lagging with respect to the voltage, so you can apply the compensation with the positive value. Okay, so by using the up button you can apply the positive value, current value, reference value. Okay, so you can see when my value is 0 0, then it is voltage and current is properly lagged. Okay, when I am apply the positive value, compensation value, then it will try to compensate the power factor. Okay, so still power factor is 6.67. okay, 0.677. okay, when I am increasing, again I am increasing the value to up to 2.5. okay, and see the performance. So when I apply the 2.5 IQ ref value, then you can see it will try to reach at unity power factor, and again you can see here it is not still it is not reached to unity power factor. Then you can also apply the compensation current, so it will 3.5. okay, so now you can see the performance. So it is reached to unity power factor, and you can also observe from here. Okay, so this is the full function of STATCOM with open loop and closed loop system. with R load and RL load, RL load and RC load. Thank you.